Okay, this is the coral heat stress user SST requirements task team. So we've got co-chairs of myself and Jonathan Mittaz, and this is the list of the people that actually contributed in the last 12 months. The list of members is a lot longer than that, but generally speaking, as usual, there's only a handful of people that participate. So the purpose of this task team is to help the GHRSST community understand the needs and requirements for the biological world in terms of sea surface temperature, to help them understand how the biological world view the sea surface temperature products that we produce, and to try and help by suggesting weaknesses from the perspective of biologists, and rather than just being trying to talk about weaknesses, we also want to participate in helping to provide suggested. We don't really have an expected closure. We're just going to keep going while we can, and each task usually has the aim of producing a paper, a document of some sort that around, or a presentation. So, sorry, we had 3 official tasks, and we inserted 1 new task while we were going along this year. So the first official task was to update the coral heat stress user requirements document. We do plan to do it next year. Task 2, this is the one that's taking most of our effort. Investigate the strengths and weaknesses of physical retrieval versus regression-based sea surface temperature retrieval over coral reefs. The main people involved in this are myself, merchant Andrew Norrie, who works with me back in Australia, Owen Embry, and Prosenjet. We chose to use AXPO as our regression-based algorithm and CCI as a representative of the retrieval algorithm. So I'm going to give you some of the a look into some of the results we've had. We've got this is going to concentrate on two sites. One, Florida Keys. Dried Tortugas is right at the end of the Florida Keys. So the satellite pixel, note the 5 kilometre scale down in the bottom right. That shows you that how big a 5 kilometre pixel. And level 3, by the way. Arlington Reef in Australia, near Cairns, and where the temperature logger and the satellite pixel. So this is just an example of a comparison at Arlington Reef during the night, METOP A, which is where AXPO outperforms CCI fairly comfortably. But it's an extremely good example of the challenge that I have with comparison. AXPO is reprocessed about a month after real-time data is collected, and you only get to process data. And I'll show you the effects of, or what we think the effects of reprocessing slides. So the AXPO, the top 2 graphs show you all of the data that we could collect for this particular site through the period that we're looking at. On the left-hand side is AXPO, on the right-hand side is CCI. CCI clearly has quite a bit of cloud in that. Pretty certain we used the right quality flags. However, nothing to say that Andrew didn't misinterpret my my instructions and use some of the others, but I think he used the correct flags. Interesting thing here is that just from the get-go, you've got almost half the number of Expo, half the number of data points Expo than you do AI. Probably showing that Expo is throwing out not only a lot of cloud, but a hell of a lot of good as well. So to make this comparison more fairer comparison, I chose to match up or pair up the pixels. So if I didn't have a data point from each of Expo and CCI, same spot on the same day, then I didn't use it. So that, as you can see on the right-hand side, paired it. Now for Arlington, the bias results, the right-hand side are only for data above the stress threshold site, 8.6 degrees. Example from the dry talk 2 is over in Florida. The results on the right-hand side are 20. All data above 29.5 of 9 degrees. This is an interesting example. First of all, it's interesting from the perspective of the number of values, all the data versus paired data, fairly even. But it shows that Expo badly overestimated, had a positive bias, whereas CCI did a job. This is, so far from what we've seen, very typical daytime NOAA 19. It's also typical for VE. This is the actual Expo reprocessed results compared to time. And you can see it actually only cleared out a little bit of cloud, cooler portions. This basically means that it's a very hard quality control and cloud detection process in the first instance. So they're throwing a lot of data away. Summary, and you can see the two standout spots for these two sites, for day and night. This total summary of the results. Mean bias, it's absolute bias, so that the positive and negative bias don't even themselves out. And you can see that Expo is up around 0.2 degrees, whereas CCI is down around 1. Over on the right-hand side, that's the worst case scenario, if you like, and Expo's worst case scenario of degrees for these examples. CCI is at over 0. So in this instance, on average, CCI seems better. So the take-home story for this at the moment is, or the summary is, Expo is basically speaking, during the night, both algorithms work well, but during the day, Expo seems to have some problems. NOAA 19, and this is, I said, well, it does really well with MEDOP A and B. We're going to continue this, and we're aiming for published paper. Task 3 is a effort to apply metrology techniques to the GHW product, is a heat stress metric. We think this might be the first time that someone actually attempted to apply metrology to both the and to a product that has both a biological dairy, biological. And we're going to continue this. We're aiming to publish a paper. Task 4 was looking at, given the problems that are happening over in NOAA, there's a chance that so far this hasn't happened. Good, but there's a chance that Coral Reef Watch either might find themselves without their system or might meet their demise as well, the other colleagues. So I thought it made sense to show you what it's like if you try and take the Coral Reef Watch GHW product and apply it modern day data set like CCI. This is the algorithm. It's actually very simple, and if you look up the paper, describe it very well. But it's basically find a threshold, derive a daily anomaly, and if we apply this to Lizard Island on the Great Barrier Reef, what we get is the usual result, which is where CCI is much lower than Coral Reef Watch product. For a reef over in northwest Australia, you get a weird situation where Coral Reef Watch is the higher value than CCI for the first half-ish of the data set. This is, by the way, stretching from 1985 right through present. And CCI is higher for the last half of the data set. Then you get a situation where occasionally, this one's Caribbean, they're the same pretty much. So it's all over the place. And here's a plot of 4, 5, 6 reefs for 2015 to 2024. And as you can see, can't even, that red line, by the way, is the 45-degree line, one-to-one line. So, oops, it's all over the place. Not like you can calibrate it. Question is, why is this happening? The largest reason, but there are others, is that the climatology from coral temp has a cool bias. And on the Great Barrier Reef here, the stress threshold comes from February, and that has a nearly minus 0.2 degree cool bias. So if we apply, if you think, oh well, okay, we'll use the that as our we'll use that as our climatology. These are the results. CCI in this instance with CCI climatology low, and the green is when you use CCI with climatology, it seems to have improved it and it's good. This instance, the old climatology makes CCI too large, especially in the first part of the data set. In this case, CCI started off being not too bad, and the old climatology made it go dry by quite a bit. Take-home message here is that the DHW algorithm might well be a simple algorithm, but applying it to a data set other than Coral Temp 3.1 is very difficult. Okay, so this is the task team in general. Challenges, basically all of this work is unfunded, so most of the work is done in our spare time, and we are looking for funding, and we think we might have an idea that might help us. That is that we would like to expand the task team to include non-coral applications regions, and therefore we propose that marine heat stress task team coral in there. It might open up some